Section 6.3 Confidence intervals for population proportions. Section 6.3 Objectives: how to find a point estimate for the population proportion, how to construct and interpret confidence interval for a population proportion, and how to determine the minimum sample size required when estimating a population proportion. Population proportion. So before we go into the definition of population proportion, I want to explain the type of situation in which we would like to estimate the population proportion. Let's say in the university, we would like to know the proportion of students that live on campus. This is a population parameter, and in order to estimate it, you will need a point estimate, and the point estimate you will get it from a sample. You will go collect a sample of a student, certain number of students. We're going to see how many we need and all that. But you collect a sample and then you ask them which ones of those students live on campus. And then, let's say you have 50 students and 5 live on campus. Your point estimate for the proportion of students that live on campus, it will be 10%. What is the population proportion then, that we denote by this letter P? Is the probability of successes in a single trial of a binomial experiment. That value is P. In the case that we just discussed, we can interpret the idea of selecting a student, and then what is the probability that this student lives on campus? Well, it will be the probability P of having a success in this single trial of a binomial experiment. That's the interpretation of this population proportion P. As we discussed in the previous idea, right? What is the point estimate for that population proportion? Is given by the proportion of successes in the sample and is denoted by P hat. The number of successes in your sample divided by the total number of elements in your sample. And this number here we call the sample proportion. X is the number of successes in the sample and N is the sample size. Now, the point estimate for the population proportion of failures is 1 minus P hat, which we call Q hat. Example: point estimate for a population proportion. In a survey of 1,550 US adults, 1,054 said that they use Facebook. Find a point estimate of the population proportion of US adults who use Facebook. The solution: the number of successes is the number of adults who use Facebook. That value is 1,054. The sample size is 1,550. So the sample proportion is, we just take the quotient of these two values, and this is 68%. Finding then the point estimate for P is just following this formula here. Number of successes in your sample divided by the sample size, and that will give you the point estimate for the population proportion. As in the previous sections, we would like to build confidence intervals for a population proportion. A confidence interval for the population proportion P is going to be built by finding a point estimate and then a margin of error. And we are going to build the interval by subtracting the margin of error out of the point estimate. This will be the left end point of the interval, and the right end point of the interval we're going to build by taking the point estimate plus the margin of error. And then the margin of error is going to be built pretty similarly to what we did in section 6.1, using the critical value for the standard normal distribution corresponding to a certain level of confidence, and then this value. Okay, this is like the standard error, but this is the standard deviation of the distribution of the sample proportions. Is going to be the point estimate for successes times the point estimate for the failures divided by the sample size, and then you take the square root. And the interpretation of this number again, this is the standard deviation of the distribution of the sample proportions. If you were to, in this example, collect several samples, calculate the sample proportion for each one of those samples, and then you were to build a distribution under certain circumstances that we're going to see in a minute, that distribution is going to be approximately normal, and it will have expected value equal the population proportion and standard deviation, this value here. The probability that the confidence interval contains P is C, again, assuming that the estimation process is repeated a large number of times. Pretty similar to what we did in section 6.1. So this is a review of the steps that you need to follow in order to construct a confidence interval for a population proportion. So the first thing you need to do is you need to identify the sample statistics N, the sample size, and X, the number of successes in your sample. Once you have those two values, then you find the point estimate for the population proportion that we call P hat. P hat is calculated as the number of successes divided by the sample size. And then you have your point estimate for the population proportion. Then you need to verify that the sample distribution of the sample proportion can be approximated by a normal distribution. Now the conditions are here, and these are pretty similar to the conditions that we use when we wanted to approximate a binomial distribution with a normal distribution. N times P hat has to be greater than or equal 5, and N times Q hat has to be greater than or equal 5. Remember that P hat is your point estimate for the probability of success, and Q hat is the point estimate for the probability of failure. And remember that Q hat is 1 minus P hat. If these two conditions are verified, then you can use the normal distribution to approximate the distribution of the sample proportions. And the distribution of the sample proportion is going to be then approximately normal. And it will have a mean equal to the population proportion that you don't know, but you want to estimate, and the standard deviation is going to be given by this expression here. P hat times Q hat divided by N, and then the square root. Once you know that, then you need to find the critical value C sub C that corresponds to a given level of confidence. And to do that, we use the standard normal table again. Then you need to find the margin of error. The margin of error is made up of two pieces. It's one product, the product of the critical value and this value here. Okay, and remember, this value here represents an approximation of the standard deviation of the distribution of the sample means. Then we calculate the left endpoint and the right endpoint as before. We take the point estimate minus the margin of error to get the left endpoint, and the right endpoint is the point estimate plus the margin of error, and the interval is this. We interpret this the same way that we did for section 6.1. If we do this process many times, we can guarantee that approximately C% of the intervals contain the population proportion. Example: constructing a confidence interval for the population proportion. Use the data in example 1 to construct a 95% confidence interval for the population proportion of US adults who use Facebook. Our point estimate was 0.68. The point estimate for the population failure is 1 minus 0.68 or 0.32. N is 1550, and we need to verify that we can use the normal distribution to approximate the distribution of the sample means. We calculate these two products, N times P hat, which is greater than or equal 5, and N times Q hat, which is greater than or equal 5. So then we know that the distribution of the sample proportions is going to be approximately normal, and the mean of that distribution is going to be the population proportion, and the standard deviation can be approximated by this formula here. If the level of confidence is 95%, we know that the critical value for 95% is 1.96, right? We did this several times in section 6.1. Then the margin of error we calculate by just replacing the values into the formula. So it will be 1.96 times the square root of this product here. If we calculate this, we get 0.023. Then we take the point estimate and subtract the margin of error to find the left endpoint, and we add to the point estimate the margin of error to find the right endpoint, and this will be the interval. So then we can say with 95% confidence that the population proportion is between these two values. And remember, the interpretation of the 95% confidence is that if we generate several intervals with this procedure, then 95% of those intervals will contain the population. We can graph the interval, and you will see something like that. This is the interpretation again of the interval. Second example, constructing a confidence interval for P. The figure below is from a survey of 800 US adults, ages 18 to 29. We would like to construct a 99% confidence interval for the population proportion of 18 to 29-year-olds who get their news on television. We know that 50% of that population get the news from radio and 5 from newspapers. So then this will be 27% our point estimate of the population proportion. P hat is 27, Q hat is 73, and N is 800. So now we need to verify if we can use the normal distribution to approximate the distribution of the sample proportions. We calculate 800 times the point estimate for P, 800 the estimate for the probability of failure. They turn out to be greater than or equal 5. So the sampling distribution of P is approximately normal. So once we know that, then we can calculate the margin of error. To calculate the margin of error, we need the critical value. And the critical value, right, we are going to do this critical value for the 99% confidence. So we go to the standard normal table and we find this value. And then we just plug those values into the formula. So this is the critical value. This is the point estimate for the probability of success, point estimate for the probability of failure, sample size, and we get this value here. And we proceed as usual. Point estimate minus margin of error to get the left endpoint. Point estimate plus margin of error to get the right endpoint. And this is the interval. We can graph it, and with 99% confidence, you can say that the population proportion is between 23% and 31%.